I want to welcome you to our 4-H QuaranTEEN Science Café. I'm Laura Wilson. I'm a 4-H science professional. I'm really glad you could join us. 4-H is a community for all kids with programs that suit a variety of backgrounds and interests and schedules and budgets, from in-school to after-school. We have clubs and camps. Our positive youth development programs are available in your community. We welcome every kid who wants to have fun and learn and grow. 4-H is the youth development program of the University of Maine. We're brought to you by the University of Maine Cooperative Extension. Just so that you all know, I'm going to end this poll in just a second. Most people on here have voted, but just so you know, we cannot see you. We cannot see your video at all, and we cannot hear you. So the way to communicate with us is through that chat box or through the question and answer tab that you have too. And thank you for voting in the poll and telling us how you heard about us today. That's really helpful for us. So I hope that you're taking that minute to introduce yourselves. Here at UMaine, we have Dr. Vanessa Klein and Alice Philbrick. They're monitoring the chat box for us today. We also have Jessie Brainerd, who is hosting that Q&A. She's working behind the scenes, and all of us together are hoping that this runs really smoothly for you. We're going to keep the session super simple. Our guest is going to share some of his cool science and tell a bit about himself. And then we'll have plenty of time for you to ask questions. So we'll use that Q&A box at the bottom of your screen to get questions to him. You're going to be invited perhaps to share some answers in the chat box as well. A note about that chat, we want to see your reactions to what our guest presents. We appreciate that, but keep that on topic as much as you can. Keep the language clean and appropriate so that we can keep that open for you. And have some fun today. I'm super excited to have Dr. Jason Bolton here with us today. Dr. Bolton, would you tell our participants about yourself and your work? I'm going to stop sharing my slides so you can share yours.
Terrific, thank you. Hi everyone, Jason Bolton here. I'm the food safety specialist for Cooperative Extension, and I also teach courses online in the School in Food and Ag. And I also, and on campus when campus is open, and I also teach and run something called the Foster Innovation Center, which I'll tell you a little bit about in a bit. So we'll get started here. I have a little presentation for you and a short video, and then I'm happy to answer questions. Okay. So I'm going to talk a little bit about food science and the science behind food. So just so you know who I am, once again, I do not have, there are not four of me, but this is an image that we did for a promotional video, which I'll show you a little bit later. And it talks about some of the work that I do with food companies. So I'm the food safety specialist, and I'm also the academic director of a program called Innovation Engineering, which I'll tell you has very little to do with engineering. It has more to do with solving problems and coming up with ideas. Okay, so my story starts, I'm originally from Phoenix, Arizona, actually a town called Chandler, which is a little bit outside of Phoenix. So I grew up about 2.5 hours away from a very big hole in the ground called the Grand Canyon. And so I've been up there multiple times, and I saw some family that lives out in Arizona. But once I finished high school and I was trying to choose a college, I was trying to figure out what I wanted to study, and I found food really fascinating. So I wanted to find something where I could utilize food in something maybe that I could study and then do as a profession. So growing up in Arizona, we have the Grand Canyon. I was also surrounded by a lot of cacti, so saguaro cactus, or cacti, I should say. And beautiful place when you get out in the desert, you get out in the northern areas and the higher elevation, but where I lived, we saw less of this stuff and we saw a lot of traffic, and it's gotten worse and worse. So the general Phoenix area is very, very populated, and they have over around 7 million people in the state of Arizona, and the largest portion of them are populated in Phoenix. So I knew when I was choosing this next step in my life, I wanted to do something that was really different. So I started looking at colleges, and when I started searching for areas where I could study food, I found something called food science. So it's where scientists look at different aspects of food. We'll talk about that in a little bit. So when I started searching, I spoke to also a couple family members, and one of the family members was a professor at the University of Maine. He said, "Hey, we have a fantastic food science program at the University of Maine. You should come check it out." So in 2002, I packed up my bags and I moved to Maine. So I traveled over 3,000 miles to get here. And I entered in 2002 as a food science major at the University of Maine. And when I got here, it looked like this. Shortly after, which I wasn't quite prepared for, and I knew it was coming, it looked a little bit more like this, which is still very pretty. So I like that very much. I got used to the cold. So I went from a place where it's 110 to 115 degrees during the summer to a place where it feels like it's negative 110 during the winter. No, maybe not that much, but it's still very cold here. But I like it a lot. I love that we have wonderful seasons here. So let's talk a little bit about what food science is. So before I give you the answer there, let's do a quick poll question. So what do you think food science is? What does a food scientist do?
Jason, they're really quick today. We've almost got 85% of them have already voted. So I'll be able to close the poll in about 10 more seconds, and then I'll share the results.
Okay. Okay, so what do we think? Well, good. Okay, so the answer I was looking for is we use science to study and develop food. There is always a kind of a comprehension of nutrition. I wouldn't ever consider myself a dietitian or someone who studies dietetics by any means, but you have to work with folks that have that knowledge so that if you're going to develop a food that has to have certain nutrition, then you have that knowledge in order to do that. And yes, we work with farmers, but not that much. I mean, really, when a farmer grows the food, a food scientist's job really steps in after the food has been harvested. So you've pulled it out of the field and brought it to a place where you're going to start to chop it up or to, as we call that, process or manufacture different foods. So it could be things like baby carrots, stuff like that. So the true definition of food science is a scientific discipline in which biology, chemistry, and physical science, like physics, are all used to study different aspects of food. And there are different subdisciplines. There's actually about probably 10 different subdisciplines of food science. But some of the more exciting ones, so what do you do with food science is you could study food and then you would look at different aspects like food safety. So here's some E. coli bacteria. So we might want to look at how we could prevent E. coli bacteria from getting on food and then someone could eat it and then could get really sick. So my area of expertise is food safety. I want to prevent people from getting sick after eating food. So it's not only just cooking the food right, but it's also when you're in a big manufacturing facility, making sure that folks are doing things correctly, people that work there are doing things correctly to make sure that that food is okay for you to eat. There's also food chemistry. So an aspect of food chemistry that maybe you've seen at the grocery store are these things like Beyond Burger or Beyond Meat or Impossible Burger, where it's a burger, looks a lot like it should be made out of meat, like from a cow, but it actually is plant-based. So food scientists and chemists have worked to develop these products so that they mimic or look like and taste like eating a burger that's made from a cow. And that has all kinds of potential possibilities for being a more green or better for the environment because cows take up a lot of energy to produce. But they're not there yet, and we're still going to eat meat for the long term, I would predict. We also have food analysis. So when you develop foods, you have to know what type of nutrition, what type of chemicals are in the food. And don't forget, chemicals are not always bad. I mean, there are a lot of chemicals like sugars, and water is a chemical, and different carbohydrates and protein. that are in foods that are really good for you. Same thing with vitamins and things like that. So not all chemistry or chemicals are bad, but we have to be able to analyze those things to determine what's in them and how much, so we can tell people whether the product might contain a lot of a nutrient or not a lot of a nutrient. So we can actually develop methods for testing these things using really expensive high-tech equipment. And then product development. This is probably one of the more exciting topics related to food science. So these are the folks that are out there, and they use an aspect of food safety and food chemistry and food analysis to develop new food products. So you've maybe seen in the grocery store all kinds of kind of gluten-free or different flours you could use to make all kinds of different baked goods that are not from wheat. So things like coconut flour, and there's tiger nut flour, there's cauliflower, which is now a flour. They take cauliflower and they dry it and they turn it into a flour. So we have all these different food products that are really exciting that you see in the grocery stores that are developed by food scientists. And then there's food sensory analysis, which is also really exciting. So this is giving food to people and then getting ratings about the food. So do you like the taste? Do you like the texture? Do you like the color? How much would you pay for it? Is it too sweet, too salty? Things like that. So once you develop a food, you have to test it with people. And if you're developing a food for a certain population of people, like kids, then you need to test it with kids. So here's an example of a product that I had some colleagues that ran the taste testing, the sensory analysis. So using senses, the taste, sight, and so forth, in order to determine how people like the food. So they actually tested this with, believe it or not, a bunch of kids. And this is made out of oat milk. So they take oats, like your Quaker oats that you might have for breakfast, like oatmeal, and they soak it in water, and then they extract a bunch of the nutrients from the oats and create essentially a dairy-free milk, which they can then add bacteria to, very good bacteria, that how we make yogurt, and then they make a yogurt from it. So I've had this product before, at least similar products, and it is very good. So how did I get here? I got here through a fair amount of hard work, but it all started in 2002 when I moved to Maine and I enrolled in the food science program at the University of Maine. So in the food science program there, let's bring that back real quick. The food science program there, I worked on a lot of things, including a food science and a chemistry minor, but that little dessert that just flew by was something that we developed in a product development class. So that was called Yobon Blueberry Bites. It was blueberry frozen yogurt, Maine wild blueberries, covered in dark chocolate. We ended up winning a major competition with that and started a small company as a result of it. So 4 years for my bachelor's in food science, minor in chemistry. And then I did an MS in food science, a master's in science in food science. And I developed this sensor here, which is a lobster health sensor. So we're able to take a small light probe, put it on the surface of the lobster to tell us how healthy the lobster is. And why we might want to know that is because we want to send healthy lobsters really far distances, like people that want to eat them in France or in China or any other place where you might have to ship it from Maine and it has to get there alive. So we developed a sensor for determining the health of lobsters. So that's me in a lobster pound where after they catch the lobsters or trap the lobsters, they bring them to different pounds. And this is a dealer that let me borrow a bunch of lobsters. And it doesn't hurt the lobster. The lobster's just kind of hanging out there while I hold my little light probe against it. So I ran a lot of studies related to that and developed a sensor. And then I did my PhD work. So that was about 2 years for my master's and my PhD work. So here's some of the stuff I studied. I know this might look kind of crazy to you, but these things right here, these are molecules. And so there are a whole bunch of different little pieces that make up these molecules. Well, where we're going to find these things is if anybody eats hot sauce or anything spicy that's made with peppers. So these are called capsaicinoids. And these are different. You can see the little changes in the way that these things are drawn out. So here's a little double bond here, but there isn't one here. That's a totally different molecule. And so I studied those in different types of peppers. We studied over 700 different types of peppers, real big ones and then really tiny ones. Some of them that I tasted and they were so spicy I started to tear up and sneeze and cough. So they were very hot, but they contain these compounds. And this one, capsaicin, is the most spicy or most intense. But I looked at these compounds and then also a really closely related group of compounds that have one change in their structure. And as a result of that, they're not spicy at all. so your mouth can't detect them. But they're really good for you, and they've been proven to help prevent things like cancer and other terrible diseases. So I studied those in different varieties of peppers. This is what we call a chromatograph. So it's a graph of a bunch of chemicals going through this little column. So we pass them through. And as they're going through this column, imagine like a toilet paper roll. Some of the molecules like to stick to the sides of this toilet paper roll, and some of them don't, or the paper towel roll. And they pass through at different rates. So that's what these things are right here. These little numbers here are actually minutes, so how long it takes to go through and separate. So what I went and I analyzed different things in lobster blood, because some of these proteins that are these different types of proteins, there's 4 different types of proteins here, 1, 2, 3, and 4. They actually have been proven to be really helpful for biomedical research, so research to help develop things like vaccines, maybe even vaccines like vaccines for coronavirus. So they found that these proteins are really good at helping develop vaccines. So I was analyzing them in lobsters. So I would take out the lobster blood, which is called hemolymph. And in the chat box, maybe we'll do a quick kind of impromptu question. Does anybody know the color of lobster blood? And unfortunately, I can't actually see the chat box right now, so maybe Laura, if you want to shout out a couple colors to me, what do we have?
We have blue, 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 and blue.
Excellent, 100%. That's correct. So it's blue when it is oxygenated. So when oxygen is in their hemolymph or their blood, it's blue. But when you take away the oxygen, it actually turns a slightly pink color. And that pink color are actually these chemicals called carotenoids, the same things you find in carrots, or at least closely related, or tomatoes. And that's the same thing that's also found in the shell of a lobster. So those carotenoids are floating around in their blood, and they deposit on the shell as it's growing. And so lobsters molt, so they shed their shell and they get bigger, and then they outgrow their shell, and then they get bigger again. And they keep on doing that. They can do that for a very long period of time. I have a picture of a lobster that is estimated between 80 and 90 years old, and it weighs 29 pounds. It's huge. The claws are like this big, massive. But it's molted a lot over its life. But it has a lot of these proteins in there. So I was looking at these proteins. And then this is what we call a scanning electron micrograph. So we took and that basically is like a really powerful microscope. So I took some chemicals that you find in aloe. So the stuff that you put on your skin sometimes after you get a sunburn. So we were looking at the particle size, how big these little particles are, in a scanning electron micrograph or microscope. So we zoom in. So this is approximately, I think if I remember correctly, let's see if I can look at the scale here. So we zoomed in approximately about 1 million times what the eye can see. So it's really, really, really tiny. So these are really, 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 really small molecules that are found in aloe. So I was looking at analyzing these things because people found that consuming aloe, eating aloe can be really good for you. So we were looking at, does a particle size help with how well it can dissolve in water? So how well it can separate and dissolve in water? Because people are putting these in different drinks, different juices and things like that. So I was analyzing that. So that's the work that I did in my PhD, and that took about 4 years. But along the way, I also discovered something called innovation engineering. So this is a pretty cool program, and I discovered this in about 2010, right as I was starting to work for Cooperative Extension. And it's a really neat program. So this program teaches people how to solve problems, how to communicate the ideas that you come up with, and how to rapidly test the ideas to prevent failure, so that you don't spend a long period of time testing something only to find out it doesn't work. And this technique or this procedure of solving problems is really effective. In fact, companies like Disney, Coca-Cola, Pepsi, Microsoft, all these companies actually use a similar process to innovation engineering when trying to solve problems. It also teaches you how to do things differently. So let's say you have a certain way of doing something. We have different skills or tools, and we can teach how to do something differently. And where this all takes place is the Foster Student Innovation Center, or the Foster Innovation Center on campus. This is the building where it's housed. And we have classrooms that are shaped like garages with the garage doors, so that we kind of get the idea of coming up with the ideas for things in the garage, which is how the personal computer was invented. And then we also have an incubator space, so a space where students that are at the University of Maine can come and start businesses. And so we provide them with office space and meeting rooms and all kinds of things. So we have typically anywhere between 5 and 10 students in there running different businesses. And businesses where they're inventing new fishing tools, for example, or starting mussel aquaculture facilities or growing facilities, all kinds of different cool things. We have a company that actually developed a really inexpensive way of doing biometric and biosensors. So they put sensors all over your body, and then they're able to determine correct movement when it comes to exercise. So we have a bunch of students that are using innovation engineering to solve problems and come up with different solutions, including some really cool inventions. So one of our slogans is, we teach people how to do cool stuff that matters. So it's a pretty neat program. And then in 2010, I started working for Cooperative Extension. And then in 2016, I started running this facility. So I got to work in this facility. This is actually where my Yobon Blueberry Bites started. And this is where we had an office here. And now I run the facility and the academic program. So it's a pretty neat place. The University of Maine offers a lot of different opportunities. So what do I do as a job for the university and working for Cooperative Extension? So I'm going to show you a little video. Let's see if this works here. Stop this. Share a different screen. So this is a little video about what my day looks like from moment to moment, I guess you could say.
My name is Jason Bolton, and I'm the food safety specialist for Cooperative Extension. The job entails many things, but it does include mostly food safety, food science, essentially consulting for food businesses out there. So I'm a person that goes out there as a specialist and helps food companies with regulatory issues, development of certain food safety plans, making sure that foods are properly cooked, properly cooled, and an overall prevention of food safety, foodborne illness. Well, the ag industry in general in Maine is growing. I mean, when I first started 7 years ago, we had only a few lobster processors. Now we have an additional 6 that I've worked with, I know, and they're large processors, you know, doing 25,000 plus pounds a day during peak season.
I can't really express how valuable he's been here, helping us through many hurdles, or I should say, helps us position ourselves to avoid many problems. Jason, you know, like I said, his expertise is, it just goes without saying. I mean, he's a man.
I helped them make sure that they met all the FDA requirements, in addition to developing a HACCP plan, which is Hazard Analysis Critical Control Point plan, in addition to what's called thermal process validation. So I make sure that every piece of lobster that goes to that facility is properly cooked. And we're talking about, you know, in 1 year they did 7 million pounds of lobster. So that's a lot of product to ensure that it's safe. Maine Craft Distillery contacted me in 2012 when they started going, and they had questions about some of the new technologies for distilling, the way to amplify some of their flavors, things like that. So I was able to use less of my food safety background, use more.
Okay, we're just going to skip something real quick.
Product, which is a blueberry liqueur, and numerous other products. So anytime they have little issues related usually with food science or distillation, they give me a call and I try to help them out. I was contacted by Gelato Fiasco, I believe, in 2015, when the Blue Bell issue occurred with the listeria and ice cream. And so that kind of put them into a kind of a shocked moment where they said, okay, well, we should make sure we don't have a problem like that.
I would say that without Jason being an integral part of our safety net system, we definitely would have some challenges in getting the system put together. It's really helpful to have his resources his knowledge of what the policies, what the regulations are, and without him, we definitely would have to go to some outside sources. It would probably cost us a lot more money. So this is definitely a huge asset to have him on board, willing to help.
He's just been a great sounding board for us, coming from 5 gallons a batch to 1,000. There's some real big scaling issues and quality control as well. He's been really helpful, just kind of coaching us along.
Chris contacted me and said, we had some questions about some bottles that were actually fermenting. I helped him validate a new process to ensure that none of their products would ferment, in addition to training him how to test each product batch to make sure that there were no contaminants. So I taught him how to do essentially basic microbiology. And then along the way, as he's changed his process, increased the capacity of this facility, I've been able to help him grow and make sure that he's still producing a consistent, safe product.
If he doesn't know the answer, he finds the answers for us, you know, and he's just very knowledgeable, and I feel he has just a broad base of experience that we can just step into, and it's been invaluable to us, really.
There is no such thing as a normal day, but a typical day in the office is, could be preparing presentations for either teaching or preparing presentations for teaching an industry course or giving a talk somewhere, answering phone calls. I had 6 phone calls today, for example. Companies asking about regulatory questions, students from other universities asking about development of commercial kitchens, labeling questions, and then the typical day when I'm out driving around, those periods of time where I'm not with the food companies, I'm typically on the phone here and there, talking to other food companies. So try to be as productive as possible. Maine made, to me, means quality. It means that the folks really care about the food that they're processing. And there's something that's said when you produce a Maine product, and that's usually quality, hardworking, the things that go along with the state as a whole and the people that live in it.
Okay, so that's just an example of what I try to do to help food companies in the state of Maine. And it's anything you can imagine. I mean, it's lobster processors like the one that's right behind me. That's one of the facilities that I work with. Or it could be working with a slaughter facility that's going to do ground beef and bacon and things like that. Or I work with another company that makes gourmet dried camping food. So you can take these dried camping food, add boiling water, and then you have a great meal. So it's all over the place. Anybody that's producing food. Work with aquaculture facilities or work with hydroponic facilities that grow vegetables and water. So it's anything in the state of Maine, and I also work internationally and across the US. So it's a really fun job, and you get to meet a lot of exciting, wonderful people that are making fantastic foods. So I have a couple quick questions for you. There's another kind of general, I think, Laura, you want to do the next question around gelato and ice cream, please? Another poll question. What's the difference between gelato and ice cream?
We'll give people a minute to answer, but I don't think I could answer this question. I don't think I would know the answer to this. So if you don't know it, feel free to guess. I think I set these up anonymously, so nobody will ever know what answer you provided. But I'm pretty sure I'd get this one wrong.
Well, I know I got it wrong before I started working with Gelato Fiasco. I really didn't understand what gelato was, and they made it very clear to me.
We're at about 80% of our participants have voted, so I'll give them about 10 more seconds, see if we can get a few more answers in.
Okay, maybe we had some fast Googlers, I don't know. Okay, yeah, so the correct answer was gelato has less butter fat in the ice cream than ice cream. So the big difference really is less fat, believe it or not, even though it has kind of a creamier texture. It typically is actually served warmer, somewhere around 10 degrees Fahrenheit warmer. Gelato is Italian, and it uses a large number of egg yolks. So gelato uses a large number of egg yolks, and that's how it's able to create that kind of creamy texture. In addition, gelato has less air incorporated in it than ice cream. So ice cream really focuses on very high fat, butter fat, typically no eggs, or maybe 1 or 2 yolks, but very small amount, or they use something called a emulsifier, so it actually helps the fat and the water that's in the milk bind together so it doesn't try to separate. And it's a very different product. So it's a very Italian, a lot of rich different flavors, things like that. How about a quick, another quick question? This is just a verbal one. You can write in the chat box. How many people, or who's had gelato, and what's your favorite flavor? Doesn't even have to be gelato fiasco, just any type of gelato. Maybe there's some wild flavors out there. Vanilla, okay. Oh, cinnamon and triple chocolate. Are those? I wonder if those are separate flavors. Banana. Haven't had it. Hazelnut. Oh, okay, there you go. Dairy free. You know, I had a gelato that was made from it was a combination of coconut milk and rice milk, and it was actually really good. I can't remember the name of it. It was definitely developed by a food scientist. Oh, graham cracker, toasted coconut. That sounds good. Okay, so nothing too wild, but some really good flavors. You know, I don't know if you know, but they make a lobster ice cream. Anybody ever had that before? Anybody want to try it? Lobster ice cream. No. Some people are just, nope, I don't want to try that. I worked with that company that develops that, and it's a really popular place in Bar Harbor, and they sell the lobster ice cream. So not a lot of lobster in it, but it's still present. You see little specks of red. Oh, okay, someone who likes lobster ice cream, good. Don't like fish or seafood, okay. So definitely not in your ice cream, all right. And then we have another, I think I have another question there. What's the strangest food that you've actually eaten? So some really strange food that you don't see very often. Crocodile, oh, crickets, okay. Mealworms, jellyfish, flavored crickets, escargot, okay. Octopus, turtle. Well, that'd be interesting. Cricket. We've played around with some cricket flour before. In my mind, it doesn't taste like crickets. Well, granted, I don't know what 100% crickets should taste like. They taste kind of nutty, I think, like almonds almost. Escargot smells really good. Yeah, I agree. Worms. Cat, dog, bat. Okay. Interesting. Yeah, escargot is, I think if it's done right, it tastes mostly like garlic and butter. That's what I always remembered. Okay, good. Well, I'm happy to answer any other questions you have about what I do, about food science. We have a lot of students that study food science that go on and work for large and small companies, and some of them even start their own companies. So it's kind of exciting. I mean, students that have worked for Ocean Spray and Pepsi and Kashi, even some dog food companies. So dog food has to be just as safe and has to have the appropriate nutrients associated with it. And there are a lot of different types of dog food out there and dog treats.
Now, Jason, you had mentioned yesterday something about how people might be surprised which is stinkier,
oh, yeah.
gelato or processing lobster. So I'm hoping that you can answer that. The question has been on my mind for 24 hours now.
Yeah, so a lot of these different food plants obviously have different smells associated with them. So which one do you think would be stinkier? A lobster processing plant or a gelato or ice cream plant? Okay, some people say gelato, lobster. Lobster. Yeah, I mean, you have to like seafood to go in a lobster plant. So if you find that stinky to start, then that's probably going to be the answer. But believe it or not, both plants, because they've been maintained so well, they really don't stink. I mean, they have a little bit of an odor associated with what they're making, so it smells a little like seafood or a little like dairy. The stinky part is actually the trash, the garbage that's associated with them. So they all have to throw away certain things. And rotting lobster shells and stuff doesn't smell very good, but the dairy part doesn't smell very good either. And actually used grain from different brewery operations is the worst. So really, really, really stinky. And it's the way that it starts to break down, the used grain. And the grain actually, for a lot of these places, goes to farms. So there's a lot of kind of, we'll call it reuse or recycling of waste, which is kind of exciting. But yeah, if you don't like seafood, then you won't like a lobster processing plant. Okay, any other questions? Yeah, sometimes they do smell like the kind of similar to an ice cream shop, but when you're making that much of it, there's a lot that kind of spills on the floor over time and melts. And so over a period of a day, it can get a kind of a strong smell, mostly dairy smell. Any other questions?
This is Laura, and I was hoping that you could explain exactly or tell them what types of majors people go into college to study something. What kind of majors can do innovation engineering and come up with new products and new businesses?
Okay. Actually, Laura, I'm gonna answer that question, and then I'm also gonna answer, there's another question that popped up.
Perfect. Yeah, okay. Answer from our guests first, of course.
Okay. So yeah, I would say the worst part of my job, trying to think. Well, right now, the worst part is that I can't go out there and work with the companies that I normally would work with, because this is the time where a lot of companies are really getting going because their busiest time is during the summer. So that right now is the worst part, that I'm sitting at home and I only get to talk to them on email and over the phone. And then some of them actually are using video chat like Skype or Zoom or FaceTime to actually walk me through the processing plant to ask me questions, because a lot of them are still processing. So that would be the worst part right now, is that. It's my favorite part. I love the variety. I think the variety in which I get to deal with different types of foods and different questions. And I also teach 4 to 5 classes a year for students. So that's really fun to interact with different types of students, not just food science students, but to answer Laura's question, also innovation engineering. Anybody can study innovation engineering. You could be a food scientist, you could be a history major, you could be a business major, it doesn't matter. So they're tools for solving problems, and anybody can do that.
We did have a question pop up in the Q&A. Do you do any experiments with food?
Yeah, so I've done a lot of work with the brewing industry. I've done a lot of work with produce, and I work with a couple colleagues on campus. One's a microbiologist, so she studies bacteria specifically, and some bacterial viruses called phages, but she looks at bacteria associated with food. So we've done a lot of studies related to produce, things like blueberries and stuff like that. I've done a fair amount of work in the lobster industry related to designing methods for cooking without losing the texture of lobster. So it varies, every couple of years there's some really exciting and new projects that kind of go on.
We've got another in the Q&A. What's something you've developed that you are most proud of?
It's a good question. Something that I've developed that I'm most proud of. Well, the original, that food product, the Yoban Blueberry Bites, was a pretty exciting thing because the university had never won this competition. So there were 48 universities across the country, very big universities, that entered the competition, and our team won. So we were up against Rutgers, North Carolina, UC Davis, and I think it was Michigan State. So we beat some really big universities, and then we got to produce this and create a company. So that was pretty exciting when it comes to developing a product. But I've developed a lot of kind of research procedures and things that are really been exciting that folks are out there using in different industries also.
We have in the chat box, Amelia is asking, how many recipe type things have you developed that have failed?
Trying to think. Not a lot, just because I don't do a lot of product development. That isn't where I really focus my work. So, but I know that there have been a lot of failures. I mean, think about any of the products that have been at the grocery store where you see them, you know, for maybe a year and then they're gone. A great example of that is a product that went and came back, and I have a colleague that developed this product for Pepsi, and it was called Crystal Pepsi. It came out, I think, in the late 80s, and then it went away after about a year, and then it came back about maybe 10 years ago, and it was Pepsi that was clear. That was the only difference. So they had to create a Pepsi without caramel color. But there are a lot of failures in the food industry when it comes to the number of products that don't survive. Different types of. Another one I remember, which I had a colleague that worked on, was green ketchup and purple ketchup. So they were colored ketchups. Kids liked that, but people in general didn't really like that, having a green ketchup or purple ketchup.
I can remember both of those, the multicolored ketchup and the Crystal Pepsi very, very clearly, because I'm old enough. We have what in the chat, we have, what is the weirdest thing you've seen on the job?
Weirdest thing. I mean, we see a lot of kind of strange things sometimes when we visit different facilities. I remember I was visiting one seafood plant, and I was not expecting when I opened up the door that I'd be greeted by 4 basset hounds. So the big, long, low dogs. They were in the office of the owner of the company. It was a pretty big company, but it was away from the food processing. But it was quite a surprise when I knocked on the door and the owner said, "Come in," and then I was greeted by these big basset hounds that were howling and just about knocked me over, even though they're really low. But they were big dogs, so it was really funny. That was definitely one of the weirdest things.
Oh, sorry. In the Q&A, we have the question, what type of recipes are you working on now? How are they different or the same compared to other recipes?
Yeah, so like I said, I don't really work all that much on recipe or product development. If someone has a question from a food company and they're trying to develop a new product, I might help them with different ingredients or different ways of processing, because a lot of these folks started a really small batch. They might make it in a kitchen, a research kitchen, and then they have to scale it up. So they might have to go from 10 pounds to 10,000 pounds. And so I help them with the scale up of those different things. And, you know, they're all over the place, from different lobster byproduct utilization. So we might take the meat from inside around the legs of the lobster and stuff like that. And they're developing lobster ravioli and mac and cheese and all kinds of things like that. Or different snack foods related to them. So it really depends. I've done a lot of stuff lately with different beverages and things like that. So people that are making different beverages, carbonated beverages.
And we have one in the chat and one in the Q&A that kind of go together. We have one person has asked, have you worked with any big corporations? And someone else asked, what is your favorite company that you've worked with?
I don't know if I have a favorite, but I have worked with some very good sized companies. Like one of the companies I work with, they do about $800 million in sales a year. And they're a fantastic company. They own about 5 different processing plants on the East Coast and up in Canada. And they're absolutely wonderful people to work with. They have wonderful employees that work with them. They employ probably about close to 1,000 people in all those different plants. So they do lobsters and scallops and all kinds of different things. And they even host something called the Lobster and Salmon Academy. So they teach people about the lobster and salmon industry. So it's a pretty exciting, it's up in Canada, and it's 5 days, and I teach it every year. And it's a really exciting place for people to go and learn about lobsters and salmon in the industry and different food products.
Going back to the excitement that was the Crystal Pepsi and the multicolored ketchup, we have the question, was the green ketchup made with tomatillos?
No, the green ketchup was really just dyed regular ketchup. They used slightly lighter colored tomatoes so that you wouldn't impart that red pigment. So they would slightly unripen, and then they put a fair amount of pigment in there. So color. Same thing with the purple one.
All right, and in the chat we have, what personality, I'm assuming personality traits, make you successful in this kind of work and career?
I would say with my position, because I do a bunch of different things in the different directions, it's staying organized and being able to handle and juggle multiple tasks. But as a food scientist, I think you just have to have a passion for food and science, because the classes that you take as a food scientist are the same classes that you would have to take in order to go to medical school. So as an undergraduate, it's biochemistry, it's biology, chemistry, organic chemistry, microbiology, pathogenic micro, all these classes that you're going to take in order to go to medical school or dental school or any other health profession, you do in food science. And then outside of that, you're going to take a lot of these classes, except it's chemistry of food, or it could be microbiology of food. So you take a lot of these classes that are then directed towards a food media, as we call it. So it could be studying different types of food and what the bacteria does in it, or what type of proteins and things like that exist, and how do you analyze them and how do you change them. So it's all those classes, and then you have to take the exact same classes except towards food.
And in the Q&A, I think you answered this already, that it was your Yobons, but Maya's asking, what is your favorite type of food that you've made?
Yeah, I would have to say it was that, because I don't do a lot of recipe development, but I think that's one of the more exciting ones. And it was with a group. I mean, I can't take credit for myself, for just me. And in fact, one of the students, I was an undergraduate at the time, one of the students who developed it with me in this group, she now is also a professor at the university. And so we work on a lot of projects together.
And we have the question, do companies actually formulate foods scientifically to make them more addictive?
Oh, that's an excellent question. I couldn't answer that. But there are certain aspects of foods that are, we're kind of pre-programmed, our chemistry, the way we've evolved, we like. So we tend to like things that are sweet and salty and high fat. So, gelato or ice cream and all those things tend to fit a lot of those different characteristics. So we're going to like them a lot more. But I don't know, I couldn't say that they're maliciously doing that.
And we have, now I think you've mentioned lobster quite a bit in the different things. Have you ever gone lobstering or fishing yourself?
Yeah, I've been on, I've done a lot of fishing, but I've also been on a lot of lobster boats and hauled a fair number of traps. So it is an amazing trade and skill, and it's a really dangerous job. I mean, these traps come up and they weigh a lot, and they're wet, and the deck is slippery, and they have the trap hauler itself is these two spinning wheels that you can get, if you don't know what you're doing, you get a sleeve caught in it, and then you can be injured really badly. So I tip my hat to those lobstermen and lobster women that are out there fishing, and they do it also in sometimes during the weather when it's very cold and snowy. So it's an amazing, wonderful thing that still exists as a culture here in Maine, and I really very much admire that.
We've got a couple that I think are connected. We have the question in the chat, did you bake a lot as a kid, which caused you to be interested in how foods work and how to improve upon them? And then someone else has asked, how long have you been passionate about food science?
Yeah, I think I discovered food science. There was a Food Network had just started to be a thing. I think it was my senior year. It was a channel on TV. It was just starting to be a thing my senior year of high school. And I thought that a career in some sort of science was where I wanted to be, because I liked science in high school. And then when I discovered the cooking channel, there was a guy on there called Alton Brown, who's on a lot of TV shows now, but he used to have a show called Good Eats. And he talked about the science behind food. And that was one of the first times that I had actually really seen food science. I also liked, you guys probably don't know him, but he was a chef called Emeril Lagasse. I always thought he was kind of interesting and fun. And he had a lot of really great recipes, Southern Creole recipes that he did, and Portuguese recipes. And I always thought it was kind of interesting. So I would never say I was a cook or a baker, but I always found it pretty interesting and tried a couple recipes here and there. But you know, food science isn't always about cooking. A lot of it is about understanding what's going on in food. There are people in food science that spend their whole career as researchers studying one aspect of food. So the way that fats and oils interact, or the way that things could be processed differently and things like that. So it's pretty amazing what folks can focus on.
Speaking of studying specific things, do you also have to study the brain so you can develop foods that will sell well?
Yeah, I mean, there's a psychology associated with, for example, I mentioned, that's a great question, sensory analysis. So there's a psychology, you have to understand how people are going to perceive something. So how they're going to look at it. You know, the combination of look and taste and the texture of the food all matter. And so there is an aspect of psychology to understanding that, and also a science to the psychology of how people might rate something or compare something. So there very much is an aspect of psychology. I only took a couple basic psychology classes in college, and I wish I learned more. But my wife's a psychologist, so now I get educated all the time about that.
Do you ever look at something at a grocery store and think about how it was made? Does that make you want to buy it or not buy it?
That's a great question. Yes, I'll say yes to all of those things. Sometimes I'm like, oh, I'd like to try this because I heard this is a new, you know, extract from some new plant or something like that. And sometimes knowing too much about the food makes me not want to buy it at all. So there are certain things that I just don't like because of the way it's processed. I also am not always a joy to take to potlucks and things like that. So
we have an easy one in the chat. Is gelato healthier than ice cream? Maybe it's easy. You would know that better than me.
I don't know. I mean, because it has a little bit less fat in some cases, but it really doesn't, because the yolks that you're putting in there, so it has less butter fat, but the yolks that you're putting in there kind of ramp up everything else. So they're both desserts, and I don't think you're going to eat them because they're necessarily healthy. I think you're going to eat them in, you know, a relatively small proportion or portion and enjoy them as they are. So that's a great question, though.
And kind of relating to that, so if we made vegetables look pretty like cake, we may be more obliged to eat them?
Maybe. I mean, there's always that thing about hiding different vegetables in different food products. You know, if you have a smoothie in the morning or something like that, putting a bunch of stuff in there to hide the spinach or kale or something like that might make it better. But in general, people don't like certain colors of food. So if the food is brown, we may not necessarily like it except for associated with bread or something like that. So some of the colors and things like that matter also.
And going back to your love of Alton Brown, how long did it take you to decide to dive into food science after your discovery of the Food Network?
Well, I started it wasn't very long after, because I started, I spoke with an uncle who's an animal science professor at the university. He's retired now, but I spoke with him, and he actually had worked a lot with the food industry and other food scientists on campus. So he told me to look at certain different websites and things like that. And so that's how I really learned. The Institute of Food Technologists is an international organization all around food science and food technology. And so I became a member there right away as a student in college, and I've been a member ever since. And it's a really wonderful network of hundreds of thousands of food scientists across the world. So that's where I really learned a lot about food science and the different careers associated with it.
Now, here's one that I'm interested for your answer. What are a couple of things you absolutely will not buy because you know about the processing?
Let me think about that.
I'm not sure you should answer that online on something that's going to be posted live.
I doesn't like that. There's certain things I don't like, and not necessarily because they're the way they're processed, but it's just some of the ingredients I don't really care for. Like, I'm not a big fan of mayonnaise. Just something I don't love. I definitely don't like Miracle Whip. That's something, and that's not because it's what it's processed or the ingredients. Something I don't ever like. But some people love that stuff, you know. So I say with most things, it's to each their own, and certain things you might enjoy and certain things you don't. So
that was a very diplomatic answer, and I liked it. We do have someone wondering, are you a good cook?
I'm an okay cook. I wouldn't say I'm a good cook or an excellent cook. I grill. That's something I do well, and I can follow a recipe. So that wouldn't make me a good cook. I'm an okay cook.
Okay, we have okay, talking about psychology, someone saw something where someone put apple juice in a medical cup, and because it was in the medical cup, their minds perceived that it was not apple juice. Trying to paraphrase a little bit.
Yep.
Is that the kind of psychology that you study?
I mean, that's an interesting example. I think there are things where people will draw similarities to, and so we want to avoid stuff like that. And that could be kind of an analogy, but a lot of it is, and it's also cultural too. So different cultures will prefer different things than other cultures. For example, some Asian cultures really like interesting textures. So I work really closely with some really wonderful Asian chefs from Hong Kong and from different areas of China. And some of the really unique flavors and textures of food, those cultures like very much, where in the US, we may not like that, or may not be used to it, or maybe not have been exposed to it. So there's aspects of that. And they're just textures that are associated with things that we're used to, things from meat. So they might create these kind of gels out of collagen, which is found from rendering, cooking down different animal bones and stuff like that, like we would make a broth. But they might make little gels and things like that in them and put them in soups because it's an interesting texture. So I would say an aspect of some of the psychology is understanding also the culture in which someone comes from, or a group of people.
And we did have the question just pop up. What is your favorite culture of food?
Oh, that's a good question. I wouldn't say I have a favorite culture, but you know, I very much enjoy many different types of Asian food, whether it be Japanese or Chinese and different. I mean, there's a whole different provinces in China that have very different foods like we do in the US. I love Mediterranean food. I'm not real picky, so I like to experience new foods. When I've been to Scotland several times, for example, and I am a fan of haggis, and I do know what it's made out of, but I really like the flavor for some odd reason.
We have the question, have you ever tried a food and not liked it, but still helped the company?
Oh yeah, I mean, there are some companies where I don't really love the food or I don't see myself eating it, but of course I would help them. And there's a lot of people that would like that food maybe, so.
We have in the chat, I think this might be our last question, does smell truly affect our taste, or is that a physiological thing as well?
Yeah, it does. I mean, you can do a simple experiment, try eating something that has a very strong odor, you know, like, just trying to think, aspects of a lime or fruit or anything really, and plug your nose and see how well you can really taste it, just like when you have a cold. So the aspects of some of the vapor, the odors or gases that are coming from that will also affect the way you taste. So they're 100% associated with each other, correlated to each other. So, and I unfortunately, I do have a meeting at 4 o'clock with some higher ups at the university, so I do need to take off. But thank you so much for allowing me to present and participating, and thanks everyone for joining.
Oh, it was such a pleasure to have you here today, Dr. Bolton. I'm really, really impressed with the questions you got too. So thanks for taking the time to hang out with us. I appreciate it. For everybody who can stay on for just a second, I would love for you to fill out our evaluation. That'd be really helpful for us because that helps us to know that we should keep doing these. So I appreciate your input. And I'm going to share my screen really quickly so that you guys can see where you can learn more. So to learn more about 4-H in Maine, visit our website. We do have an ongoing series of these 4-H QuaranTEEN Science Cafés. Next week, we are going to have Dr. Danielle Levesque and she studies mammals in exotic locations and here in Maine. So she's going to share some of her adventures working with tenrecs and tree shrews. So I'm excited to hear about that. I know she's done some work in Madagascar, so I'm very excited to see what she brings to our discussion next week. And I want to thank everybody for coming out today. If you enjoyed our Science Cafe, just a reminder, University of Vermont 4-H is also offering virtual cafes, and theirs are on Wednesdays at 3 p.m. We do have a link to their website from ours. And we've got more upcoming events that are going to be added to our registration site soon, from archaeology, bioengineering, GPS technology. We've got those all slated for future Tuesday afternoons here in Maine. So stay safe, everybody. Continue to keep washing those hands, and we hope to see you here next Tuesday afternoon. And thanks to the team behind the scenes, because that's the way this all gets done. It takes 4 or 5 of us to get this online. So I appreciate my colleagues and their help. Thanks, everybody. Have a great week.